Hey, welcome in today's session on advanced features in Azure Web Apps. My name is Peter. You can ask me any question throughout the session using social media or send me an email, peter@pdtit.be. To share a few words about myself, I'm an Azure architect and trainer traveling the world to provide Azure readiness workshops to Microsoft partners, Microsoft larger customers, and even Microsoft internal. I'm a Microsoft certified trainer for a bit more than 10 years, an Azure MVP for 4 years in a row, an Azure Advisors member, and in 2016 I worked a couple of months as an FTE in the Azure engineering team as a program manager. In my free time, I'm still trying to keep myself busy with the Azure and the Microsoft world by writing books, creating courseware, and overall being a technical writer. Early 2017, I started my own Azure-focused community, AzurePlatformExperts.com. The agenda for today's session is pretty light, which obviously doesn't mean that the session is not covering a lot of interesting stuff. I'm going to start with why using Azure Web Apps, followed by the core topic of today's session, Azure Web Apps Advanced Features, and obviously trying to spice up the session using quite a lot of interesting demos. Now overall, when talking about Azure Web Apps, it's quite important to understand that most of the features that I'll talk about in the session today are not just valid for web applications, but also for the other Azure application components like mobile apps, logic apps, and API apps. But since the session is only about 30 minutes, I'm going to focus on doing demonstrations around web apps for now. But again, a lot of those features are similar for the other application services as well. Now, when talking about advantages of using Azure Web Apps, why? Because like myself, I have a pretty deep IT pro background, and for quite some years in the Azure world, I was focused around Azure infrastructure. So why, as an IT pro, why should I worry about using Azure Web Apps? Well, first of all, because in the end, it's mainly running IIS or Apache-like web servers without the servers. You don't need to deploy any virtual machines, no operating systems to manage, to patch, to maintain, or even better, to troubleshoot. Azure Web Apps by itself is scalable, highly available, and reliable from the core. A lot of the features that I'll talk about are based on what's called an Azure Application Service Plan, which somehow points to a monthly cost, but even more important, giving you a lot of interesting features. Azure Web Apps also runs web applications in a similar way as running inside virtual machines, but in my opinion better. And it has a lot of advanced features, and even some of them are not available when running web servers within virtual machines. Now, starting with my first demo, what is an Azure Web App? Now, pretty simple. Within my Azure world, I have my application services, and in there I have a unique named website that, as you can see on the basic monitoring here, that it's actually running. And if I go to my URL, then you can see that my web app is running. So this is a pretty basic ASP.NET web application that's being deployed out of a Visual Studio deployment wizard, pushing it out to the Azure world, creating a web app environment, and my website is running. Obviously, from here, I'll drill down in a lot more advanced features, but still relying on the same demo website. Now, when I'm talking about advanced features, I'm mainly focusing around 3 core domains: deployment, security, and scalability. Deployment is mainly pointing to 3 specific features: deployment credentials, deployment slots, and deployment sources. And obviously the remainder of the session will drill down on each and one of them. From a security perspective, I'm going to talk about authentication features, SSL certificates integration, and service identity. And from a scalability perspective, that's the real feature or the core feature around using Azure application services on top of the Azure scalable platform, where I'm going to talk about scale up, scale out, using auto scaling, and, for example, performance testing. Now, quite important, I'm only highlighting what I think are some interesting features out of the advanced features here, but know that it's not mapping all available features of Azure Web Apps. There's a lot more, like backup, like logging, which I'm not covering in this session. So drilling down on a couple of those aspects, starting again with the first pillar, deployment. Deployment credentials, deployment slots, and deployment sources. Deployment credentials basically points to defining a Git or FTP account for automating your Azure Web App deployment. Now, quite important, the account that you define there will be used for all Azure applications across all your Azure subscriptions linked to your Microsoft account. So it's like in the good old days when you were creating a web server and you hand over your FTP credentials to a developer. Whenever the developer needed to push out updates to the web application, the only application he could use was FTP, using credentials, uploading the content, and the new version of the website is live. And this is pretty similar, still valid in today's Azure Web Apps world. Deployment slots is another interesting feature. It allows you to run different runtime environments, for example, test, development, staging, but each and one of them is running independent from each other. Next to that, you can perform a slot swap, moving from one slot to the other without migrating any data whatsoever. Now, quite important, deployment slots require a standard or higher application service plan, so it's not available in the free or the basic plan. Last one around deployment is deployment sources, where it basically points to synchronizing content from a cloud storage environment, for example, OneDrive, GitHub, Bitbucket, Dropbox, and a couple of other ones. So once you deploy your web app, it will create a specific folder in any of those cloud storage environments and synchronizing content, which is giving you another deployment method where you can just upload new content into OneDrive, Dropbox, or any of the other ones you're using, and your web app content will be updated immediately. So let me walk you through a couple of those settings specifically around deployment from within my Azure portal. So again, using the same demo website here, starting from deployment credentials. So what I can do from here is providing an FTP account, providing a password, confirming this, handing over those credentials to, for example, my developer workforce whenever they want to use any or they push out any updates to the web app coding, they need to use those credentials. If you're wondering what the FTP address is, then from the overview pane here, it's automatically creating an FTP endpoint, where by default it's using the website name and the FTP PDT account, which is dynamically generated, but nothing blocks you from defining your own and obviously specifying your own password credentials. But most important will be the FTP host name. And as you can see, there's an FTP one, FTPS, secure FTP, which obviously would be my personal recommendation to be used. The other feature I was talking about is deployment slots. So what a deployment slot again is doing is providing you a way to deploy your same web application in a couple of different ways. For example, test, staging, production. So what I'm running here is my production deployment slot. This is my live website. Now when I'm adding a slot here, I can define, for example, staging, and defining if I want to clone it from any of the other environments. This shouldn't all take that long. There we go. My new slot is deployed, and if I select any of these, then you can see that it's actually creating a completely new website. Because what it does here is creating a similar named URL, but this one is pointing to staging, as you can see up here. And obviously if I would go in there, my website would still be running. Now next to that, another cool feature is not just having a different URL, but it also allows me to swap content from one environment to the other. So for example, swapping from staging to production, or the other way around, where imagine that you're pushing out quite a lot of updates and all of a sudden your website is not running anymore. Then instead of troubleshooting, you can easily perform a swap and going back to the previous stage. That's the whole idea about using deployment slots. Then the last option I was talking about around deployments is deployment options or deployment sources, where you can define any of those cloud storage environments. So keeping it easy for now, let's say OneDrive, since I don't have any subscriptions in the other ones. So what I did here is defining OneDrive as my source. I need to provide my OneDrive credentials, defining a specific folder, which by default is the name of my web app, and that's about it. What it does is basically creating a specific folder in OneDrive. The folder is named Apps, in which it creates an Azure Web Apps folder where it allocates a specific subfolder for my specific web app. And within the web app, it's basically copying, synchronizing my actual web app files. So it could be like a copy. Now instead of giving access to a developer to the Azure portal, defining admin rights to upload web app content, the only folder you need to share and give access to would be OneDrive. The developer pushes out code, updates to OneDrive, the syncing process kicks in, and you have the new version of your web app up and running without touching the Azure backend whatsoever. Pretty cool features if you ask me. So with that, let's move on to the second pillar, security, where I'm going to talk about authentication, SSL certificates, and managed service identity. Around authentication, it's a pretty cool feature. Now, by default, any Azure web app is configured to use anonymous logon, which means no authentication. It's like the default in IIS, by the way. Now, out of the authentication settings, it allows you to directly integrate authentication directly from an Azure web app layer without modifying your application code. So you don't have to go over to the developer asking to modify the web app coding, which by the way might be in some kind of legacy format but still running on the Azure web app layer. But imagine that you want to provide some more intelligent security and forcing users to log on first before authenticating, or maybe you've been running the website on an internal web server running within an Active Directory domain and relying on Active Directory credentials as a security mechanism, where once you start migrating your web app to Azure, there's no way you can integrate it with your Active Directory. You could use Azure AD or integrating with some other social media accounts, identity objects like Facebook, Google, or Microsoft account like the former Live ID. From SSL certificates, I assume that you're familiar with what SSL certificates are doing. They're allowing your traffic to the web application being encrypted using an SSL certificate, where Azure gives you a couple of interesting options. You can upload your own SSL certificate from your own certificate authority or any public one. Single namespace wildcard certificates are all supported. Or you could also use an application service import certificate, where instead of going out to a certificate authority, the provisioning process is done out of the Azure environment. Once you have your certificate, you need to provide SSL bindings, pretty similar to how you're doing it on an Apache or IIS web server. And most important, coming back to those application service plans, SSL bindings or SSL certificates in general can be used from the basic plan or anything above the basic plan. And then lastly, managed service identity. It's basically an application service account allowing you to integrate with other Azure platform services, where the identity itself is based on an Azure Active Directory service principle. So it's like creating a specific user account, like a service account, in your Azure AD environment and reusing that service account to connect to other Azure platform services, like SQL databases, DocumentDB, and table storage, any other Azure component you can think of. So with that, moving on with a couple of other demos here. So from my website environment, I'm now moving over to authentication as the first one. So what I'm going to do here is activating application service authentication. And as you can see up here, the default is allow anonymous requests. So that changes to Azure Active Directory, where obviously next to that I have to define my authentication provider. For now, I'm just selecting Express, which gives me the advantage that all the technical settings, like an Azure application ID and such, is being created automatically for me. So I'm going to create a new AD application, giving it some clear name. And not to forget saving my settings. What happens now, once I go over to my web application, and giving it a little bit more time. There we go. It's now immediately integrating with Azure Active Directory. So asking me to authenticate here, and if you're familiar with like Office 365, Dynamics, then you're probably familiar with this logon behavior. And once I'm authenticated, I get access to my web application, where again, I didn't make any changes to the coding, just migrating code from my on-prem web server into an Azure web app environment, Azure web app environment, and next to that, enabling the authentication feature from within the web app itself. The managed services identity is the section here, where I can define here to register my service identity in Azure Active Directory. Where again, it will be seen as some kind of service account, where the service account can be reused to connect to other Azure platforms. So if I go to my Azure AD, then in here I can point to application registrations, which would be the same as what I showed you, but using the manual configuration. Or next to that, linking to any of my Azure AD user accounts, where from here, instead of using the services identity, I could create my specific service account, pretty similar to the iUser account in IIS in the good old days on a web server on the Windows operating system, but now making it a bit more secure by moving to service accounts. And lastly, the SSL certificates option, where again the first thing you have to verify is that your application service plan is configured to support SSL certificates. Next to that, up here, you can upload your certificate or import one using the cloud provisioning system. And once you have your certificate available, you can add your bindings, where you define your custom domain based on the certificate and your SSL type, which can be explicitly IP based or using the standard server name indication. Which for me, being an IT pro, and somehow, I don't know how many hundreds or maybe 1,000 web servers I've been deploying in my 20 years I'm working in IT, but this is all pretty similar in behavior, in configuration, which also makes it interesting as a step up learning curve in migrating from on-prem web servers into the Azure web apps. Shouldn't all be that difficult. Which brings me to another section here around some advanced features, drilling down on scalability, where I'm going to talk about scale up, scale out, auto scaling, and performance testing. Scale up, scale out is easy. Scale up points to selecting the correct application service plan, allowing scale up. Scale out is the actual scaling configuration, where you define a specific instance count as a maximum setting to grow or to shrink. Now, most environments are pretty dynamic. Like, think of a web application like a web shop, for example. You could start pretty light, assuming that only a handful of users are connecting to the web app on a daily basis. But once your web application or the website becomes pretty popular, then there might be no way to somehow estimate your overall user behavior, which means that you need some kind of auto-scaling. And that's where a lot of on-prem environments are actually going down. Since the more users are connecting to your web application, the heavier the load on the servers, the easier it is to somehow crash your environment. Because once you're reaching the maximum capacity of your servers, the only thing they can do is crash. That's the only thing they do when they can't deliver the performance. And overall, with all the other cool things in an Azure environment, this is one of the true features of using Azure Public Cloud as a scaling platform. So by using auto-scaling, instead of defining an instance count, we're going to use the automatic intelligence based on the web app needs, where you can define scaling based on a metric, like if CPU goes above 90%, deploy an additional instance of the web app. It will slim down the CPU performance to like 70% on average. More users are connecting, you deploy an additional metric, defining, again, if CPU of those two instances goes above 90%, then install a third instance, a 50th instance, maybe 5,000 instances. And once the traffic performance goes down, it will also automatically scale down the amount of instances. Obviously, to make it a bit more intelligent, you need to define some rules and configuring instance limits. And then the last feature I want to highlight here is performance testing. That really allows you to scale traffic between a deployment slot, for example, beta or staging, and a production, where the total always needs to be 100, but it's divided based on a configuration setting that you define. Like, for example, 25% of my users will go to production and 75% will still be redirected to the staging environment. Where again, pretty similar to the previous flow, moving over to some demos again. Starting with the scaling features. So the first thing you have to define is selecting the correct application service plan. Because what you can see here, if I drill down on some of those, in the premium series, it allows you to scale up to, for example, 20 instances, where if I go down to the standard plan, it's only allowing me a scale up to 10 instances. And in the basic plan, it's only 3 instances, and the free and the shared don't support any scale up. So that's the first setting you have to define. Next to that, in the scale out option, you really define your scaling metric, where you can see here my instance count for now would be 1, and nothing would block me from defining, hey, scale up to 7 instances all running at the same time. Now this is all fine, but somehow it's still pretty static. So more interesting is using auto scaling, where I'm really gonna use the intelligence and the power of the platform based on a metric, or again based on a specific instance count, where most customers obviously would go for a metric, where I pre-configured the rule whenever my CPU percentage for this specific instance goes above 80%, deploy an additional instance. Where next to that, to somehow keep cost in control, I can define the minimum and the maximum limits of my scaling options. Because otherwise it could still just grow and maybe never shrinking down, where at the end of the month, when you're getting the bill out of your Azure consumption, maybe it's not the best solution at that moment in time. So, which basically means that you're misusing the power of the platform. And the last option I talked about is testing in production. So what this allows you to do, again, is splitting up traffic between deployment slots, where I could define send along 25% of the users to staging, and the other 75% immediately go to production. And again, the routing will be handled out of the Azure Web App platform by itself, but allowing you to, for example, redirect users only in a limited way to staging and slightly moving more to production, or obviously the other way around when you're a bit anxious in pushing out your production website to all users. So just a couple of features again that I think are pretty interesting. So this was in short I would say 9 core features I would like to talk about. Now there's another feature that somehow is interesting to mention, giving you some nice advanced integration. It's Azure Virtual Networking. Now Azure Virtual Networking out of the Azure Web Apps in the platform as a service is interesting, since VNets are basically infrastructure as a service. And that is the true power about this configuration. What it allows you to do is building out hybrid connections, where hybrid can be between IaaS and PAAS. For example, an Azure Web App connecting to a SQL database in an Azure virtual machine, or even hybrid in an on-premise scenario, where a SQL database or any other data source, if you want, is running on premises, where to allow a hybrid connection, you could also go for the true infrastructure-based scenario using site-to-site VPN, but using a hybrid connection where you deploy the hybrid connector settings in your on-prem environment, it will immediately define an integration from your Azure running web app into your on-prem virtual machine. And the last setting you can define there are IP restrictions, where you define and manage rules which IP ranges can manage or even connect to your Azure applications. And the list must be a static IP address or an IP range. Now the last feature I want to talk about is a little bit away from web apps as such. It's Azure Application Insights, which is basically the go-to monitoring tool for web applications. Where, interesting enough, although it runs as an Azure service, it supports Azure running web apps and hybrid, like a web server that's running on premises. And in short, it allows you to detect and diagnose issues in your web applications by using a couple of different settings. Application map, just one of them, live metric stream, availability, performance, and emulating end users connectivity. So just some screenshots, and again, I'll just gonna do it immediately, jumping to an Application Insights demo. So within the Azure portal, whenever you deploy your web application, it's not enabled by default. I can only recommend to just go out and enable it. So again, for my demo website here, as you know, it's already running. So what I can do is go to, for example, Application Map. Now this is a pretty basic web application that's giving me some details on overall performance, overall availability, and any other failures if they would occur. From here I can drill down into another logging component in the Azure platform called Log Analytics that somehow looks and feels like Power BI, where based on a pretty intuitive, intelligent query language, I can really drill down and getting some nice diagrams or output of my web app behavior. Or using live metrics, giving me some overall diagrams based on, or showing me overall health, server requests, amount of HTTP requests, things like that. Now again, this is just a pretty lightweight environment. I don't have a lot of users connecting, if not actually just myself. That's why the graphs are not really showing a lot of information, but based on the colors, I think it should be obvious how easy it is. And again, you just enable Application Insights without requiring any specific additional agents, deployments, developing whatsoever being required. So pretty cool features. Or the availability testing I was talking about. So what you can do here is really testing out the overall load of your servers. So what I did here is scheduling a deployment test where it's activating the test across multiple US-based locations every 20 minutes, every hour, every 24 hours, and 72 hours, where for now my availability is 100% and the average test duration, emulating 250 users connecting to my web app, is taking me 1.5 seconds. So pretty interesting numbers if you ask me. And again, this is all about testing if, for example, your code is ready for high available, highly scalable web environments. So with that, we're close to the end of this session in which I talked about Azure Web Applications and drilling down on specific advanced features and moving to a couple of demos in between. So with that, thank you very much for watching my session. Hope to see you again in any of the future ones. Again, don't hesitate to reach out or connect on social media or sending me an email. Take care for now and talk to you soon.